section 1.4, we're talking about measuring and classifying angles here. First of all, some very important terminology with angles. In order to name an angle, there's a couple different ways you can do it. Sometimes you can just name it with a single letter, and that letter is at the vertex. The vertex is like the corner. The corner is an unintelligent word. In geometry, we use the word vertex. Your two sides are two rays. Remember, a ray is when it has one endpoint and it continues forever in one direction. So you can name it just using the vertex. So I could technically call this angle A. But instead of writing the word angle, we draw an angle symbol, which looks just like this dude over here to the right, something like this. Angle A, hooray. The second way you can name an angle is to use three letters. In this case, we use letter C from one side, the vertex, and then B from the other side. Now the order doesn't matter as long as the vertex stays in the middle. So I can call this CAB, vertex in the middle, or I can call this angle BAC, vertex is still in the middle. Okay? This one will work every time. The first one will only work sometimes. So you may be asking yourself the question, well, when is a time that number one doesn't work? Well, we'll talk about that a little bit later in this video. As usual, pause if you're not done writing yet, otherwise, next slide. So, here is an example where we can't use one letter. If you were to just say, well, we're naming the three angles in this picture. There's a small one at the bottom, a medium one at the top, and then the whole thing. If you just called this angle X, how do I know which angle X you're talking about? Are you talking about the medium one? Are you talking about the small one? Or are you talking about the large one? I have no idea because they all have a vertex of X. So when you have multiple angles that have the same vertex, you have to use three letters. I'm going to say that one more time in case you want to write it down. When you have multiple angles that share the same vertex, you have to use three letters. So in this case, if I want to name the large one, I'm going to start with one side of the large one that has W, and then the other side of the large one that has Z. So I can call this angle WXZ or ZXW, as long as X is in the middle. For the medium one, if I trace it, I need to use X as my vertex, so in the middle. I need to use 1 point from one side, 1 point from another side, so W and Y. And then for the tiny one at the bottom, X is the vertex, I have to use Y and Z. Again, I could do ZXY if I wanted to, as long as X is in the middle. So that's how you're going to name them. To classify them, this should be a review, so I'm going to briefly talk about it. You can pause it if you need to. An acute angle is an angle whose measure is between 0 and 90 degrees. It's small, so people may say it's cute. I know it's a really corny joke, but it helps students remember. You've probably heard it before. A right angle is exactly 90 degrees. You know something is a right angle when it has the right angle box in it. An obtuse angle is in between 90 and 180, so it's larger than a right angle. If it's 180 degrees, like a half circle, 180, if any of you skateboard or anything like that, a straight angle is a straight line, and it's 180 degrees exactly. Pause if you need to, otherwise we're going to move on because that's a review. Here's a challenge problem. How many angles are there? We're not going to talk about it in this video, but if you want to pause it and try it, you can. We're going to be looking at something like it in class later. Using a protractor to measure and classify. We'll do a couple of these. We'll do some more stuff like this in class later. If you're honors, if it's regular, if you're in my regular class, this is just a review for you. So use the diagram to find the measure of the indicated angle, then classify it. So KHJ, I'm going to start at K, trace it to H, and then trace it to J in order. Well, here it starts at 0 and ends at 55. So that's a 55-degree angle. It's less than 90. It is acute. For GHK, I'm going to trace it. G, H, K. Starts at 0 on the top numbers, so I'm going to use the top numbers this time. It's halfway between 120 and 130, so that's 125. I didn't just guess. I mean, you can count these little ones here. There's 5 of them to give you 125. But your screen's so small you probably can't see it. It's larger than 90, but less than 180. It is obtuse. So I'll just do those 2 for now. This one's interesting. Draw a pair of opposite rays. What type of angle do the opposite rays form? Remember, an opposite ray pair, they go in opposite directions but share an endpoint. I totally put this out of alphabetical order. Forgive me. Opposite rays, like I said in the first video, form a line. So that's a straight angle because they form a straight line. Really, though, in geometry, there's no such thing as a crooked line. Now, if I have a crooked line, that's not a line. That's 2 line segments put together, or 2 rays put together. Okay? No such thing as a unstraight line. All right, for angle measures, how do we show that angles are congruent? Well, congruent angles have the same measure, just like congruent segments have the same length. Excuse me. To know that they're congruent and they have the same measure, you put one little curve mark in each of them. Or they could both have 2 curve marks, as long as they have the same number of curve marks. When I'm talking about the actual size of an angle, like let's say this is 30, I would say not just that angle A is 30 degrees, I'd put a little m, because I'm talking about the measure of angle A, okay? If you're talking about a measure of an angle, you're going to use an equal sign. If you're talking about the actual angle as a physical object itself, then you're going to use a congruent symbol without the m. You do not want the m. You're not talking about a measure anymore. You're talking about the physical object. Just like with segments. If you're talking about the size, you use an equal sign. If you're not talking about size, you use a congruent sign. The angle addition postulate is just like the segment addition postulate. If you have multiple angles, like here we have 3 and 1. We have a large one, we have a top one, and a bottom one. Let's say the top one was 30 and the bottom one is 40. Well, what's the whole thing? What's the measure of angle RST, the whole thing? We'll add the 2 pieces together. It's 70. So that's your angle addition postulate. You can add the 2 angles together to equal the largest angle when you have something like 3 and 1 like this. Again, don't worry about the number. I just want you to remember the name. We're going to use that later, like in chapter 2, to construct some arguments, all right? So for this one, I'm told that the measure of LKN is 145. We're going to find those other 2 angles. In order to make this simple, I'm going to label my picture. LKN, I'm going to trace that. That whole thing there, here, that whole thing is 145 degrees. My first half is 2x plus 10. The second one's 4x minus 3. You cannot assume, just by looking at a picture, because it looks like it, you can't assume these 2 small angles are the exact same size. So you cannot set them equal to each other. The only thing we know for certain is if you add them together, they'll equal 145, the whole thing. But I know some of you will still want to set them equal to each other because it looks like it. In geometry, we always need proof. Just because something looks like it might be true is not enough anymore. The only thing we know to be true, because of the angle addition postulate, that if you add these 2 together, it'll equal 145. So now that we have our equation, we can solve for x, and then to solve for our angles, plug x back in. So I'm going to combine like terms, and then 10 minus 3 is 7. That equals 145, and I'm going to bring my 145 down. I'm going to subtract 7 from both sides and get that 6x is equal to 138. And then divide both sides by 6. I don't know that off the top of my head, so I'm going to pause it and go figure it out. All right, figured it out, so x is 23. 23 is not your final answer. The problem doesn't ask you anywhere up here to find x. X is a part of the process. It's not the answer. We're looking for the measure of angle LKM, and we're looking for the measure of our second one, MKN. Well, if I look at my picture, LKM is this first half, 2x plus 10. I know x is 23, so it's 2 times 23 plus 10. Order of operations says multiplication comes first. So 2 times 23 is 46. Add that 46 to 10, you get 56. So your first answer is 56 degrees. For our second angle, it's 4x minus 3. We know that x is 23, so I'm going to plug it in. 4 times 23 is 92, minus 3 is 89. Now, if I want to check my work, if I add this, which is, 56, my other one, which is 89, if I add them together, I should get 145. If you don't believe me, check it for yourself right now. If you add 56 and 89, you get 145. So our answer makes complete sense. Just like segment addition, but only dealing with angles this time. I don't think we need here. No, we don't need that practice. All right, so like we talked about with segments, a bisector passes through the middle. We talked about a segment bisector passing through the midpoint. An angle bisector does the same thing. It divides something in half. It cuts it off into 2 sections. All right, that are equal. So in this case, we're told these 2 halves are both equal. We're told that x, y, w, which is the angle at the top, is 18. So I'm going to label my picture with what I know. And I want to find out what x, y, z is, the whole thing. Well, if this is a bisector, that means if this half is 18, so is that half. So if I want to find the whole thing, x, y, z, I'm going to add my 2 pieces together. 18 plus 18 is 36. Let's do one last problem. Yeah? No. No, I think we're done. So hopefully that's helpful for the angles. It's all you need to know, again, for honors. This is the first time you're seeing it. We'll do some collaboration in class. Those of you that are regular, it's a review. Maybe you were absent. I don't know. But hopefully it was helpful for you.